Oh, hello. I've got a problem. I've got some sodium hydroxide, 1 molar sodium hydroxide. I made this myself out of some drain cleaner. That drain cleaner is pretty much straight up sodium hydroxide. So I made that, but I've also got some sulfuric acid is in there. I made up a dilution of that, but I'm not sure if it's right or not. So I've got a bit of an issue. What I'm going to do is I'm going to do a titration of sulfuric acid into this and see if we can work out the concentration of the sulfuric acid. I'm just going to do a really rough one first, and then I'll do a more accurate one later on and see if we get roughly the same result. But I'll just show you that's what a titration is for. It's to work out the concentration of something. So that's what we're going to do. But first thing, we need to put on our safety equipment. Right, here's my sodium hydroxide measuring cylinder. I'm just going to do this the rough and ready method. So we're not going to use a burette. I'm just going to measure out 10 cubic centimetres of that, pretty good. Chuck that in there. And I'm going to titrate that with that. First thing we need to do is turn that a nice colour. I'm going to use this stuff, which is phenolphthalein. It's an indicator, you've used it before, and it goes pink in alkali. So let's see if it goes pink. Hey, lovely, a few spoonfuls of that, and droppers I should say, and there we go, it's pink. Now what we're going to do is I'm going to put 10 cubic centimetres of my sulfuric acid in here, and what we're going to do is see how much of this it takes to turn that colourless. Okay, just clean out my pipette, and we're just going to put it in. If you can have a close-up of this, and you'll see that as I put it in, we're doing it over a white tile, or a piece of paper in this instance. As we put it in, it's slowly going to change colour. So I'll chuck it in, keep going. Okay, so it's not done yet. Keep it in, keep it in, a little bit more. We want it just to change colour, and at that point the exact amount of sodium hydroxide and sulfuric acid are the same, and then we can see how much acid we used and work out the calculation. That you can see it's going now. It's just about to go, and that's what we want. A very, very faint pink. That's gone now, and we can. It's just visible as a pink, virtually gone. And if we look here, we can now see how much acid we used, and we've used about 5.8 cubic centimetres. That is the number that we're going to use for our calculations, and they are coming up next. Okay, we're going to try our calculation now, and this is for our rough titration. So the first two things we need are the mole triangle, which is this. Mole equals vol times conc, and we need the balanced chemical equation, which is sodium hydroxide plus H2SO4 goes to sodium sulfate Na2SO4 plus, we've got water, acid plus base goes to salt plus water, and then we need to balance it up. I've got two sodiums over there, so I need two over there, and we've now got 4 H's on this side, 2 waters, so we need 2 of those on that side. What we're really interested though is this and this. So for the sodium hydroxide, we know we had 10 cubic centimetres of it in our beaker to start with, and we need to convert that to decimeters. So that is going to be
0.010 decimeter, or just 0.01 decimeter. You just move the decimal place 3 points to the left or divide it by 1,000. So that is our volume for NaOH. So volume we've got, and now we need to get our concentration in there. We've already got the concentration because we were told that it was 1 mole per decimeter is the concentration, and we want to work out how many moles of this NaOH we've got. So moles equals volume times conc, volume times concentration, and we got both of those now, so pretty straightforward. So moles equals our volume, which is in decimeters, which is 0.01 decimeters, times 1 mole per decimeter, and that's going to equal 0.01 moles of sodium hydroxide. Okay, so we've got the moles of sodium hydroxide. So now we need to look at our acid. The most important thing now is if we look at this molar ratio, I've got 2 of those and I've only got 1 acid. So my ratio is NaOH to H2SO4 2:1 ratio. That means we can work out how much acid must have reacted with that sodium hydroxide. So if I had 0.01 mole of my sodium hydroxide, I must have 0.005 mole of H2SO4, because if we see our equation, 2 units of sodium hydroxide reacts with 1 unit of acid, so 0.01 mole of sodium hydroxide is going to react with half as much, 0.05 mole of sulfuric acid. So we now have got the moles of sulfuric acid. We know the volume was 5.8 centimeters cubed, and how do we know that? Well, that's the amount that we literally tipped in from the measuring cylinder, so that's how much we measured. And we need to put that into decimeters, which is 0.0058 cubic decimeters. And now we're in business, because for working out the concentration, if we look at our moles up here, we want to work out the conc. So the concentration is mole divided by volume. And we've got both of those now. Here's my volume, here's my mole, so we just plug them in and see what happens. So mole 0.005 mole divided by 0.0058 decimeters equals 0.86 moles per dm. You see the units work nicely, and that is my concentration of H2SO4, which, considering when I was diluting it I was trying to get it to about 1, that's not too bad. Okay, there's a rough titration. Next step, we'll go off and do a more accurate one.